Thermochemistry.
Thermochemistry is the study of chemical reactions that include heat.
Heat is measured in Kelvin, Fahrenheit, and Celsius and joules. Temperature is the average kinetic energy.
The reaction can be either exothermic or endothermic. When heat is released to the surroundings and work is done by the system, it is exothermic. When heat is absorbed by the system and work is done on the system, it's endothermic.
In our example, the system is open, which means that energy and matter can be transferred in and out of the system and shared with the surroundings.
Our example is a car. The system is the whole car, including the engine, and the surroundings is everything else, for example, the road and the people.
The first law of thermodynamics is that energy can never be created nor destroyed.
Energy is the capacity to do work or transfer heat. Kinetic energy is the energy of movement, and in our example, it is when the car drives and the fuel is being used. Potential chemical energy is the stored energy which is in the fuel of the car.
Internal energy is the sum of all kinetic and potential energy in a system. Internal energy is changed by work and heat and is measured with the formula delta energy equals Q plus W, or change in energy equals internal energy final minus internal energy initial.
Heat capacity is an extensive property and it depends on the mass.
Heat can be measured with the formula Q equals mc delta T, where m is the mass, c is the specific heat capacity, and T is the change in temperature. Specific heat capacity is measured in joules per gram per Celsius and is the amount of heat required to change 1 gram of a substance by 1 degree Celsius.
Molar heat capacity is measured in joules per mole per degree Celsius and is the amount of heat required to change 1 mole of a substance by 1 degree Celsius or Kelvin.
The formula for heat capacity is the heat absorbed, Q, divided by the mass of the substance, m, times the change in temperature, T.
Enthalpy H is used to measure how much energy bonds have and how much they gain or lose when they undergo a reaction. H is equal to E plus PV, where E is the internal energy, P is the pressure, and V is the volume. The change in enthalpy is equal to the change in internal energy, so the change in H is equal to the heat.
State function. The path independent, for example, mass, volume, pressure, or enthalpy, depends only on the present state and not the path it took to reach it.
Standard enthalpies of formation. The enthalpy change that occurs when 1 mole of a substance is formed from its elements in their standard states under standard conditions. Standard conditions are the temperature is 25 degrees Celsius and the pressure is 1 atmosphere.
This is an example of the change in enthalpy of formation and how it's equal to the sum of the change in enthalpy for the product minus the sum of the change in enthalpy of the reactants.
The states of products and reactants must be shown in a chemical equation, because different states have different energy levels and enthalpies. This would affect the change in enthalpy calculations.
Hess's law states that if a reaction is carried out in a series of steps, the change in enthalpy of the overall reaction equals the sum of the enthalpy change for the individual steps. Delta H3 equals delta H1 plus delta H2.
In this example, in the combustion of isooctane, which is the fuel we use in cars, the isooctane and oxygen are the reactants, and the carbon dioxide and water are the products of combustion.
Calories and joules are both units used to measure energy. Joules are the SI units for energy. Calories is the non-SI unit. And 1,000 small calories equals 1 big calorie, which is what we associate with food.
By
Samantha?
Simone.
and Kirsty.